We can use the product rule of differentiation when we are working with exponential and log functions. For example, here we've got y equals t cubed times by the natural log of t squared. So we have an exponential function and a log function multiplied together. So we know when two functions are multiplied together, we can use the product rule. We're going to denote the t cubed, the exponential function, as u, and the log function as v. And to simplify further, using our rules of logs, when we have a power, as we do here, we've got a 2 in the exponent, we can move that to the front. All right, so that's what we have here. So the product rule is set out below, and if we are wanting to find the derivative of y with respect to t, the product rule tells us that we must differentiate the first function, which we are calling u now. Okay, differentiate u with respect to t. So we will end up with 3t squared. All right, just using the power rule of differentiation. Then we're going to leave the v function in its original form. Okay, so we'll leave it as is. All right, and that's what is written down here. Then we have plus. All right, then we have to find the derivative of v with respect to t. So that there now is the logarithmic function. We now need to find the derivative with respect to t. So we have to remember how we differentiate natural logarithms. And remember now we've got this 2 in front, which will remain. All right. And then the derivative of the natural log of t is just 1 over t. So when we find the derivative of this, we're going to end up with 2 over t. All right, so this here would be 2 over t. And then the last part, we have to leave u in its original form, so it's t cubed, and we have that down here. All right, so we've applied the product rule, and now it's just a case of simplifying. And if we look at this term here, we are multiplying 3 by 2, and we end up with 6t squared times by the natural log of t. Okay, plus, here we can simplify. We've got a t in the denominator and t cubed in the numerator. Okay, so one of these can cancel, and we end up with 2t squared. All right, and the last step is to factorize. So what is common to both of these terms? And it would be 2t squared. Okay, here we've got 2t squared as well. If we take that out, we are left with 3 and the natural log of t plus 1. All right, and that obviously in brackets and 2t squared in front. Sometimes we can use logs to make differentiation easier. For example, if we are given this here, y equals x squared divided by x plus 3 times 2x plus 1, we could differentiate using the product and quotient rules that we learned about earlier on in the course. But now we know, now that we know how to differentiate logs, an alternative approach can now be to take natural logs of both sides, simplify using the rule of logs, and then differentiate. So if we do that, taking natural logs of both sides, and then using our rule of logs, remember when we have a log of a quotient here, what we can do is take, and in this case we're working with natural log of x squared minus the natural log of whatever is in the denominator. So here we've got the numerator, here we've got what's in the denominator, and we can further simplify using the log rule that applies with respect to products, where here we've got x plus 3 multiplied by 2x plus 1, and we can further separate this out, and we would take the natural log of x plus 3 plus the natural log of 2x plus 1. Now that we've taken the natural logarithm of both sides of this equation, what we need to do is differentiate both sides of the equation. So we will start with the left-hand side. So differentiating the left-hand side with respect to x. On the left-hand side, we've got the natural logarithm of y. And recall that for the natural logarithm of y, y is simply a function of x. Okay, so we can rewrite this as finding the derivative of the logarithm of the function of x with respect to x. And we now need to recall our rules of differentiating when we have natural logarithms. And remember to find the derivative now. It's quite straightforward. We need to differentiate this function of x with respect to x. So we need to find that derivative. So f prime of x. That will be in the numerator, and in the denominator we would put the original function. Okay, so setting this out slightly differently, okay, if we just separate out the numerator from the denominator, and we have f prime x here multiplied by 1 over f of x. And then in our final step, again, we just use slightly different notation. Instead of this notation here to indicate the derivative, we're going to use dy dx, and we're still multiplying by 1 over the function of x times by 1 over the function of x. But as we said here, y is a function of x. Okay, so we can replace f of x in the denominator here with y. Having done that, we now need to differentiate the right-hand side. Okay, so now we are going to differentiate the right-hand side of the equation with respect to x, and we are still using this rule of differentiation with respect to natural logarithms, and we need to apply this to each of the natural logarithms that we now see on the right hand side. Okay, so starting with the natural logarithm x squared, okay, we need to differentiate x squared. Okay, so that would be 2x. Okay, so that would be f prime x, 2x, and the original f of x, okay, would be x squared. So that goes into the denominator. All right. Minus, we now need to take x plus 3 and work out the derivative with respect to x. And here's just this term x that has x in it. And finding the derivative with respect to the power rule, we would be left with 1. Okay, and then f of x in its original form is x plus 3. So there it is in the denominator. Okay, and we'd have a minus sign here because remember this minus sign we would multiply through by. So we'd end up with a minus here. And finding the derivative of 2x plus 1, okay, with respect to x, we would end up with 2. All right, and then f of x in its original form is 2x plus 1. Alright, and that's what we have in the denominator here. Alright, so we've now differentiated the right-hand side with respect to x using our rules for differentiating natural logarithms, and we can simplify slightly now, particularly this first term here where we have x in the numerator and x squared in the denominator. Alright, so we can cancel here and we would end up with 2 divided by x. Alright, so we've now differentiated the left-hand side and the right-hand side of this equation, and we can now set the two equal to each other. Alright, so this is the derivative of the left-hand side that we worked out on the previous slide, setting it equal to the derivative of the right-hand side, okay, all with respect to x that we worked out up here. Alright, and by multiplying both sides by y, right, we can isolate dy dx on this side here, and we would have all of this in green over here multiplied by y on the right hand side. Here we have another example. If we are given this function here, okay, for y, and we are asked to differentiate y with respect to x, taking the natural logs first can make this task somewhat simpler. So let's do that, taking the natural log of both sides. Okay, we end up with this down here. And now we can apply our rules of logs yet again. All right, here we've got x to the power of a multiplied by e to the power of kx minus c. All right, so we know that we can rewrite this as follows: natural log of x raised to the power of a plus the natural log of e raised to this power here. Okay, and we can further simplify when we have a power like this. We've got x raised to the power of a. We know that we can take this a to the front and rewrite as follows: a times the natural log of x. All right, and working with this second term here, all right, this we can simplify to what we have at the bottom here. Okay, the natural log of e raised to the power of kx minus c, simply kx minus c. All right, so having simplified, this is what we have here, and now we can differentiate, and recall we have to differentiate both the left hand side and the right hand side with respect to x. All right, so for the left hand side, differentiating the natural log of y with respect to x, we are going to end up with this here, and this is exactly as what we saw in the previous example, so I'm not going to work through it again here. I'll leave that up to you to do that. All right, if we then now differentiate the right hand side with respect to x, okay, we need to work with each of these terms here, starting with the first one. Okay, remember the a, it acts almost as a coefficient, so we need to leave that as is, and finding if we differentiate the natural log of x, remember that's going to give us 1 over x. Okay, so we would end up with a over x when we differentiate that first term with respect to x. All right, kx, that's fairly straightforward. We just need to use the power rule that we learned in a much earlier session, and we would end up, if we differentiate this with respect to x, we would end up with k, and minus c is a constant, right? So that would be 0. Okay, so here the left-hand side and the right-hand side have been differentiated with respect to x. And now if we want to isolate dy dx on the left-hand side, all we need to do is multiply both sides by y, and we end up with this here. And as a final step, we can substitute back into y, because remember y equals all of this here. Okay, so this has been substituted back in for y, and this here would be our final answer, having been asked to differentiate y with respect to x using natural logs. Here we have our final answer.